look at chapter 4 here, the binomial expansion for year 2 or year 13. So the difference with this is before you would have been used to just positive whole numbers, positive integers for these expansions, and you should be pretty happy with how we expand these. So these numbers, sure, you can get them from a calculator now, but just remember that this all came from the choose function. So for example, the power is 5. So we said the choose function. The first position is always 0, isn't it? So 5 choose 0. 5 choose 1 for the next one, and so on. Okay? And that would allow you to do the expansion with sort of any of these cases. Okay? And the negatives was a special case where we had to be careful. So I want us to start thinking about this more in general terms, and then we can extend it to what we need to do for year 13. And the way I'd like to do that is I'm going to pick a larger one. So I want us to have a think about 10 choose 3. So the definition of where the numbers come from the calculators and all this sort of stuff, was that we have this n number. Okay, I'm going to write it in algebraic terms in a moment. And then we have this r number. Okay, that's where NCR comes from. And, sorry, we're doing it in number terms, aren't we? So if I wanted to write it out, it would be 10 factorial over 3 factorial, and then multiplied by 10 minus 3 factorial. Okay, again, this is really revision. So what's this the same as? Well, this is the same as 10 factorial over 3 factorial multiplied by 7 factorial. Okay? However, if I write this out and we see what's actually going on, 10 times 9 times 8 times 7 times, I'll go 6, all the way down to 1. And then over here, I write my 3 factorial, the same as before, but my 7 factorial, I write it out. Well, that is 7 times 6 times, etc., all the way down to 1. So hopefully you can see, by doing this, because I'm multiplying, I can cancel all of this and all of this. And the top part instead, what I'm going to do now is I'm going to write it sort of in algebraic terms. So if 10 was the n, and 3 here was the r, what do I actually have? Well, I have n being multiplied by the number below it. The number below it, n minus 1, right? The number below it again, that's n minus 2. Okay, etc., as far as you need. Okay, for the third term here, this is as far as I need to go. Okay, and then underneath, I just have the r, don't I? The r factorial. So why is this useful? Well, this is useful because it comes to make up the formula that we're going to be using in year 13. And really, it's just an extension of what you know from year 12. Okay, so it's just sort of incorporating how we're going to deal with, as you're going to see in a moment, how we're going to deal with sort of fractions and indices and so on that might be negative in the same terms. So let's try these quick examples. So what would n choose 1 be? Well, we're going to we're sort of not going to be going down at all on this one. Okay, so what are we going to have? N choose 1 is going to be when you make r equal to 1. Okay, and what we'd actually see is we'd see here that this one is going to become n. Okay, by the same logic. I'm not going to go through the whole step, but that this one here is going to be n. This one here, okay, because it's choosing 2 parts, you're going to go along twice in the chain. So you're going to have n and then n minus 1. And because your r is 2, it's going to be 2 factorial. Okay? What would the next part be? You're going to have n, and then you have this 3 as the r, so factorial. And because you have 3, you're going to have 3 terms in the top. Okay? It's easy to show how to derive this if you put some numbers in for n, but this is the pattern that will start to emerge. So for the first term, the second term, and the third term. and we'll look at this some more in the next video.